So the last thing we're going to talk about in this introduction to functions unit is sequences, and we'll look kind of at them in general. Then we'll look at ones that are more specific in those arithmetic sequences. So a sequence is an ordered list of numbers that oftentimes form a pattern, right? And so each one of those numbers in the sequence is called a term of the sequence. Okay, so we have each term, right? And then kind of looking to see what pattern is happening between them. So a lot of times when we look at kind of extending sequences, we're looking at what pattern do we see happening. So look at this first one, right? 5, 8, 11, 14. I need to look at and say, how would I go from 5 to 8? Well, I could add 3, right? And so then I want to see if that kind of keeps holding, right? So is 8 plus 3 11? Yes. 11 plus 3 is 14. Yes. So we kind of have a pattern of adding 3, right? So the next two terms are going to be 14 plus 3, so 17. And 17 plus 3 gives me 20. So that's kind of how we're going to look at kind of see this. I would usually start with saying, could I add or subtract something to get there? Does that hold true? And then if not, look at kind of multiplying and dividing. So if I look at this next one, right, 2.5 to 5, I can say, well, I added 2.5. Is 5 plus 2.5 10? No, right? So you know that it's not adding anything. So now I look and say, what could I do to multiply 2.5 to get to 5? Well, I could multiply by 2, right? Is 5 times 2 10? Yes. 10 times 2 is 20, right? That should just be a times 2. So my pattern is times 2, right? And then my next two terms would be 20 times 2 is 40. 40 times 2 is 80. So when I look at kind of getting more specific, so when we start talking about what this whole lesson is about, all right, so in an arithmetic sequence, when we have the special type of sequence, the difference between consecutive terms is constant, and we're going to call this the common difference. Okay, so anytime we have an arithmetic sequence, we are going to have the same common difference between each of these things. So if I want to look at just identifying them, right, so look at 3 to 8, right, I'd have to add 5, right, 8 to 13, I add 5, and 13 to 18, I add 5. So because I add 5 every time, right, I can say yes, the common difference is 5. Okay, so look at this next one, right, 6 to 9, I add 3, 9 to 13, I add 4. So once I get that kind of different thing I'm adding, right, this one is no, because there's not a common difference. All right, so we're going to look at kind of writing a couple different formulas here. So the first one is writing a recursive formula, right? So recursive formula kind of is dependent on what came before it. So if I look here, I know this is an arithmetic sequence, right? They told me. So I need to just figure out what is my common difference, right? So 70 to 77 is plus 7. 77 to 84 plus 7, right? And 84 to 91 plus 7. So now when I kind of look at the sequence, right, I need to start by saying what is kind of my A1, what is my first term of the sequence. So look, I can say that is 70. All right. And so how did I find A2, right? How did I get to 77? Well, I took A1, right, and added 7 to it. Same thing for the third term, right? A3 is kind of that second term plus 7. So, and then if I look at the fourth term, right, I know I took the third term and added 7 to it. So now I've got to look and say, okay, kind of how can I find the rest of my terms, right? So what about if I said, what if I wanted to know for any term, right? So I look and I say, okay, I know I need to know the term before n, right? So I'd have a to the n minus 1 term, right? And then I always added 7. So that's kind of the recursive formula. And then if I want to look and say, okay, how do I find a sub 8, right? I want to know the 8th term of the sequence. I need to find 5, 6, and 7 first, right? So I kind of have that question mark up there. I want to find 5, 6, and 7. So we're going to go down here and say, well, A5 is A4 plus 7, and I know that A4 was 91. So 91 plus 7, right, gives me 98. And I need to keep doing that, right? So A6, we know, is going to be 98 plus 7. So you get 105. A7 would be 105 plus 7. So I would get 112. And then I know A sub 8 is 112 plus 7. So it means the 8th term is going to be 119. All right, so another thing we'll talk about is an explicit formula. Right, so an explicit formula is a formula as a function rule, right, that relates each term of the sequence to the term number. So we have this kind of thing here, right? So we're going to fill in what these different things mean, right? So a to the n, right? So that is kind of telling me I'm talking about whatever term, right? So whatever term in there is the one I'm talking about. So there's the nth term, right? A sub A1 is my first term, right? And then I look at it and say n is the term number, and this d here is the common difference. Okay, so we're going to kind of look at and say, okay, how do I use an explicit formula to kind of help me see what is going to be some term number of a sequence, right? The explicit formula is going to help me find higher terms a lot easier than the example we just did where we had to go through every one. All right, so I'm looking at this this kind of online auction thing, and it wants to know what is the explicit formula to represent those bids. Right, so if I look, I've got these tables, right? I've got this table here. So 200 to 210 is plus 10. 210 to 220 is plus 10, plus 10. Okay, so my common difference is 10, right? So kind of my a sub n, right? For whatever term I wanted to find, I look at and say, what was my first term, right? So go and look here. First term was 200 plus, now I have n minus 1, right? And then times the common difference is what we just found, so times 10, right? And so now if I want to know what is the kind of 12th bid, right? I look at a of 12. Now I think about, kind of evaluating a function. You can say 200 plus 12 minus 1 times 10, and I just evaluate that, right? So I would get $310, right? So meaning that the 12th bid that takes place in this guitar is $310. All right, so the last thing we'll look at is what if they give you kind of a recursive formula, right? How could I write the explicit formula? So I want to look at and say, okay, I have this recursive, recursive formula here, right? And they tell me that the first term of the sequence is 19. So I want to write the explicit formula. So I'm kind of looking back at that explicit formula idea where we talked about that, right? A sub n was equal to the first term plus n minus 1 times the common difference, right? So if I have this kind of first term, they tell me that the first term of the sequence is 19, right? And I have plus n minus 1 is kind of staying there. And then I look up here and say, from up here, where can I find my common difference, right? So that's what's added or subtracted. So I can say times 12. And then now I have a recursive formula that I can use to find any term number.